Hi, everybody. So I wanted to go a little bit over uh, how to use Snapgene for insert insertion using Gibson Assembly. So this is going to be similar to your exam question, but also a different example. So as you can see up on my screen, I have the PET41A vector, which you might recognize from class. And then I have this gene that I'm interested in cloning. So this is the small subunit of the rubisco. And so I'm interested in cloning the coding sequence of it. Right now, I have an entire messenger RNA up, and so that is the entire sequence that you're seeing here, but only this part here is what actually codes for the protein itself. And so that is the sequence that I need and want. And so when I'm cloning it into this PET41A vector, I'm actually interested in making sure that it is fused to all of the tags that we can see here. So we have our GST, our 6X histidine, our S tag, and then there's also this 8X his tag that we have here in the end. So I want to keep all of these N terminal tags as well as this C terminal tag. So when I'm doing this, we're going to have our PET41A vector here, going to have this selected. Go up to Actions, select Gibson Assembly, and insert fragments. So in this first pane here, I've already selected my vector because I had it up, and I want to linearize it by PCR. And then what I'm going to do for my primer selection is I'm going to highlight the entire sequence that I want to replace with my Rubisco piece. So that's going to be most, if not all, of the multiple cloning sequence. So I have this highlighted. I'm going to click over into the sequence tab and then see how well that actually represents what I'm looking at here. So we can see we have all of this highlighted, but you might notice that we're actually cutting off a tiny bit of the last part of this enterokinase site. In actuality, this is actually something that I would like to keep. So what I'm going to do is I'm going to highlight from here. That way I can keep all of my codons in frame so that I still get this lysine residue created. Highlight all the way through the multiple cloning site, which leads directly up to this 8X his site. So now that I have that selected, I'm going to go over here up to the top tab, switch to selecting my fragment. And so the source file that I have here, I'm going to click over here, and it's this RBCS1 file. So it brings up my entire file that we have here. And so the easiest way for me to select the DNA sequence for this is to just click on the annotation for Rubisco. So you can see we have our start codon, and then if I scroll all the way to the bottom of the coding sequence, we can see our stop codon. So because I'm interested in fusing that C-terminal 8X his tag, I actually want to leave out the stop codon because if that is included in our sequence, it will stop translation of our Rubisco to fuse that 8X his tag. So what I'm going to do is I'm actually going to highlight starting with this valine codon at the end and then come up to where the start codon is. So now that I have that highlighted, I do have that fragment. So one of the things we also have to pay attention to is the orientation that we're talking about. So right now, our Rubisco gene is, pointing, if you will, from the left to the right and being read from the left to the right. However, if we look at our PET41A vector, when I put it into this site, I actually want it to go in the opposite direction so that it continues to read. So what I'm going to do is I'm going to click this orientation button over here just to let the software know that the fragment, I actually want them to switch around in its orientation. And so the next thing I'm going to do, going to come over to products, and then we're going to start picking some of our parameters. So in order to choose those overlapping PCR primers, you may have noticed on your exam that we told you to just use default parameters. So I'm just going to keep those as they are. Hit that choose primers button, and then we get our cloned pop-up. So you may notice at least one of the PCR amplifications will produce multiple products. So that's interesting. I look forward to seeing what exactly that's going to be. And so if we zoom out to look at our entire map, you always want to do this visual to make sure that everything went in the right orientation. So we can see that the arrow pointing on our Rubisco gene is in the correct orientation in correspondence to GST and all these other tags, which is great. If we come here and we look at the sequence, I want to go to the start codon basically of my Rubisco gene. This methionine that we have here looks like it's good and in the exact same frame as the S tag, the 6X his tag, and our GST sequence here. So then I'm going to come down to the back end here to the C terminal end of Rubisco to make sure that the 8X his tag is properly fused. So you notice I did get rid of that stop codon, and so Rubisco flows into the 8X his tag, which is good, and then we hit a stop codon at the end of that. So basically it looks like I have properly been able to fuse these a couple of things together, which is really good. And so looking even at our overlap temperatures that we have here, we can see that we have fairly high temperatures. That's okay for what we want. So it looks like these are our set of primers that we can order, and hopefully those should work just fine. And so we have our complete map. Everything looks good. You can always rename everything. But I do want to come back to this warning, which is interesting. So at least one of the PCR amplifications will produce multiple products, which is definitely an issue for us. And so one of the things that we can kind of notice is that our vector forward primer that we have here looks like it actually has two sets of locations that it's calling for where it is able to bind. So if I just zoom out to our map, notice that vector forward is here and then also up here. So there's something about that primer that has a lot of overlap that it doesn't like. And so it seems like the site for enterokinase might be a little too similar to our sequence down here, close to the ROP sequence. Although when I look at this, that is an overlap, but it looks like it's only about 11 base pairs, and the melting temperature on that is not very good. So it's going to be very hard for the primer to adhere to the sequence. So if I was doing this in real life, I would probably actually go ahead and ignore this. I don't think this would cause a lot of interference for me, and so I would go ahead and keep using this set of primers. And with that, I hope you find this video helpful, potentially a little illuminating for what was happening during our exam.